Hey everyone, welcome back to the channel. So in this video, we'll try to solve a very interesting geometry problem. The problem is interesting not because of its difficulty, more so because of an anecdote associated with the problem. Alright, so the anecdote, it goes something like this. So this problem originally was proposed in a magazine called The Lady's Diary. The Lady's Diary was an annual magazine where some problem used to be proposed, and this was one of the problem, and the problem difficulty used to vary. Some of them are very easy like this one, and some of them are comparatively harder, right? So that was good, but the problem was that this problem resurfaced in May 1952. Someone named Johanna Mankiewicz, who was a student at the time. She was a 15-year-old student of a school in Los Angeles, but she was also a nephew of a famous film producer. All right, so now this problem was given in her high school homework as her high school homework, because as you will see, this problem is very easy. Maybe some of you will be able to solve it very quickly, right? So that's why it was given as as a homework, as an assignment for her, as her homework. But because she was unable to solve it, what she did was that she wrote a letter to none other than the great Albert Einstein, asking for a help to solve this problem. And she wrote in that letter, that letter was quite famous, and in that letter to Einstein, she wrote that right now you are the only person who will be able to help me, who will be able to help us to solve this problem, which is very funny because, as you will see, the problem is very easy. And later this story was leaked, and some newspaper like New York Times and some other newspaper reported it, and the school's reputation was under question, and the principal of her school was really outrageous, because of this. And interestingly enough, Einstein actually replied to her letter, and Einstein, even though he did not really show the whole solution, but he gave her a hint. So I thought that was very interesting that Einstein, even this problem is very easy, Einstein actually Einstein had that humility to reply to a high school teenager. Anyway, so that's the story behind it. Now we'll try to solve the problem. And so the problem goes like this. There are two circles, as you can see. Two circles, you can consider them to be two pennies, different size penny, different size coins. This is a big coin, this is a smaller coin, and the radius of this circle or this penny is r, bigger r, and the radius of the smaller circle is small r. All right, and the question is, what's the distance between, this distance d, that is denoted by d? We have to find d, right? So this is basically when you kind of draw a perpendicular line from the center of this circle to this straight line, you're gonna get this point. And if you draw another perpendicular line from this point to this straight line, you're gonna get this point. And so distance between these 2 points, and we have to find d, right? So if you want to solve it by yourself, pause the video right now and think about it for a while. So I'll try to solve it. Now it's very easy, as you will see. The problem is very easy. If you, instead of trying to considering this line, we can actually consider this line here. So we will try to draw a parallel line to this line. So if we draw a line from the center of this circle to perpendicular line, basically, if you want to draw a perpendicular line from the center of this circle to this line, like this, right? This line will be parallel to this line, because as this is 90 degree, this is 90 degree, and this is 90 degree, this 90 degree, they has to be parallel, right? So what we got here is basically that we got a right angle triangle where this is the right angle, right? So we have to finding that this distance d is equivalent to finding this distance right over here. So our goal is to find this one, and as you can see, as it is a right angle triangle, we know the length of this side, and we also know the length of this side. We can actually find the length of this side using the infamous Pythagorean theorem. Now, what is the length of this side? Well, as this side is basically consists of the radius of the two circles. So basically the length of this side is r, capital R plus small r. If we combine them together, we get the length of this longer side, right? Hypotenuse of the right angle triangle, right? Now, what's the length of the smaller side of this right angle triangle? Well, the length of the smaller side is r subtracted by smaller r, bigger r subtracted from the smaller r subtracted from the bigger r, right? Because the length of this is r, because this is the radius of the bigger circle, and the length of this part is actually smaller r, because this is exactly equal to the length of the smaller radius of the smaller circle, right? So this is smaller r. As this is bigger r, the whole thing, and this is smaller r, this has to be what? This has to be r minus r, right? Bigger r minus smaller r. So as we know the length of these two sides, using Pythagorean theorem, we can try to find the length of d. So we can write it as like this. We can write, using Pythagorean theorem, we can write it as like this. We can write it as r plus bigger r plus smaller r whole square equal to, again, bigger r subtracted minus smaller r whole square plus d square, right? Now if we use basic algebra, we can write like this: d square equal to r plus bigger r plus smaller r whole square minus, again, bigger r minus smaller r whole square, right? And if we just do some basic calculation, we can write it as like this. We can, using the formula a plus the whole square, we can write it as like r square plus 2 r bigger r smaller r plus smaller square, and here you will have minus, we'll have again r square bigger r square minus 2 bigger r multiplied by smaller r plus smaller square, right? And if we do the calculation, we'll have here like this: r square and 2 bigger r smaller r plus smaller r minus, we'll have bigger r square minus 2 bigger r smaller r minus, so this will be plus, because minus multiplied by minus will be plus, and this will be minus smaller r square, and they will be cancelled out. So we'll have, there are 2 r and plus 2 r will be 4 bigger r times smaller r. This is equal to d square, right? So what's the length of d? Well, if we take a square root, we will have 4 bigger r times smaller r equal 2 multiplied by root over bigger r times smaller r, and that's basically our solution. That's exactly the length of d.